The wind tunnel model was primarily sized to meet a 5% wind tunnel blockage constraint. To accomplish this, a 1 to 30 scale was used, giving a current blockage of 4.68%. The model also needed a removable horizontal tail for longitudinal stability testing, and the model is comprised of 12 3D printed parts and 9 steel substructural components. The 3D parts are shown here, and the steel substructural components are shown here. To begin assembly, the central wing section here had the rod mounting plate inserted through the bottom, and the wing rods were then added. Once the central wing was complete, the inner and outer wing sections could be added, and the wing could be added to the center fuselage. The mounting plate was then inserted through the bottom, and the sponson plate through the side. The sponsons were then attached to the outside of the sponson plate. The nose could then be added to the forward of the center fuselage section, and the aft fuselage and empennage section could be added to the aft of the section. Once assembled, the joints were bondoed and sanded, and the model was painted with additional sanding in between each coat. The finished model is shown on the screen as well as in front of you. Now I'll go through a short video showing the assembly process. First, the inboard wing sections were added to the central wing section. Once complete, the outboard wing sections could be added. Epoxy was used on the various tabs as well as along the wing rods in the structure. After the wing was complete, the central fuselage was added to the wing section through a hole in the top and was epoxied in place. After this, the mounting plate for the balance was attached through the bottom of the center fuselage. This was fastened using 2 screws to the rod mounting plate. And next, the sponson plate could be inserted through a cutout in the side of the center fuselage. The sponson plate was also screwed to the rod mounting plate and the balance mounting plate. The sponsons were then epoxied in place on the outside of the sponson mounting plate, and the nose was added using epoxy to the center fuselage section. Next, the aft fuselage section here and the tail rod here were added to the center fuselage section. Epoxy was applied along the length of the tail rod as well as in the joint between the 2 sections. Once the central assembly was complete, the tail sections were added to the model. The vertical tail was placed with 1 small tab as well as the tail support rod. The horizontal tail had no tabs because it did need to be removable. A horizontal rod was added to strengthen the horizontal tail, and last, 2 vertical rods were added to strengthen the vertical tail as well as firmly attach the horizontal tail to the model. Next, I'll be covering the wind tunnel test procedures. All tests were conducted at approximately 136 feet per second. This velocity was determined by a maximum moment constraint on the balance. This gave us a model Reynolds number of 185,000, while the actual aircraft Reynolds number was approximately 6 million. Because of this, trip strips were used to simulate turbulent flow. All testing was conducted in the 32 by 45 inch closed return wind tunnel located in the Tracy Dorland Wind Tunnel facility at the ERAU Prescott campus. The structural model verification was then completed. The approximate wing loading was applied to test the wing structure, and the approximate tail loading was applied to the tail to test the pitching moment. UV dye testing was first conducted to demonstrate the flow over the model. The model was painted with UV dye and then photographed using black lights in the tunnel. All test cases included the horizontal tail, and the model was tested with and without trip strips located at 10% chord. Test angles of attacks were 0 degrees, stall angle of attack, as well as 2 degrees before and after stall. Force balance testing was then conducted using the Aerolab 6-component balance. Lift, drag, and side forces were measured, as well as pitching, yawing, and rolling moments. There were 4 test configurations: without the tail and without trip strips, with the tail and with trip strips, without the tail and with trip strips, and with the tail and without trip strips. Next is Ryan Williams with the wind tunnel testing results.